Okay, I think I'm live. I don't know, wallah. Okay, how can I like take this out? How do I take this out? Oh shit. Okay, and can someone this to be like an extra panel? Can I? Oh no, I want this. Hold up. Oh, okay. Can I like? Do I have to get my tab? Plus, I get my tablet. Okay. Oh shit. Oh shit. There's actually people here. Oh, okay. Guys, assalamu alaikum wa rahmatullahi wa barakatuh. Alaikum salam. Okay, for this live is just gonna be yani if anybody has questions for physics, Ya Allah. Uh, if anyone has questions for physics or anything for the periodic, just ask me and I'll solve it for you and I'll explain it for you right now. Okay, I have the chat open on my side. Just any question, maybe any specific question you have in the course division or in the quiz or whatever, uh, I'll I'll explain for you. If there's nothing, I'll just sit on my phone and I don't mind, wallah. If there's no questions. Okay. The delay is crazy, wallah. Tablet. Okay. Uh, like right now, no, I don't think explain English. Okay. Man billah. Okay. The first question I see is from Palestine. Man billah, can you re-explain number 11 in course of Jamashi? Let me see. Course physics. Yeah. Okay. Number 11. Okay. Yeah, this one. I'll start with this one. Before I start, do we need to do all experiments? Yes, you do. Make sure you memorize them. Can you explain question 12? Okay, I'll do 11 and 12 again. Do quiz. Okay, I'll start with question 11 and 12. Okay, memorize all experiments. Yes. Okay, I'll start with question 11. Before I do start, make sure tomorrow to read all the questions carefully. Make sure, because the physics regional, he will play with the questions, he will change up the words, he might say something differently. Make sure you read your questions carefully, especially in the written part. Let's start. A hot iron piece, okay, of mass 5 kilograms at temperature 60 degrees Celsius is placed in 3 liters of water in a copper pot. So the water is in the copper pot, okay? And the water and copper pot, water, 3 liters of water, and the copper pot is mass 1 kilograms at room temperature 300 Kelvin. Determine the equilibrium temperature of the system. The keyword here, guys, is equilibrium temperature. For tomorrow, okay? I'm gonna tell you something that will be very useful for tomorrow. Okay? Whenever you add a hot object to a cold object, let's say you have a hot object and a cold object, and you put them together, what's gonna happen? The temperature, they're gonna reach what we call thermal equilibrium, right? Thermal equilibrium is, let's say, this is 60, this is 30. Eventually, they're going to reach 45 degrees Celsius, both of them, right? So this is going to keep on losing temperature and this is going to keep on gaining temperature until they both reach the equilibrium of 45, right? So whenever you have thermal equilibrium, you have, again, a hot object and a cold object. The hot object will lose temperature, right? It's going to lose temperature. So this is going to be, it's going to lose energy. So which one's gonna lose? The hot, because it has extra energy, right? The hot always has extra energy. Which one's gonna gain energy? The cold. Okay, it's gonna gain temperature. So this is gonna be Q gained. Okay, in our experiment here, or in our question here, which one is gonna gain? Which one's gonna lose? Which ones are hot? Which ones are cold? Our hot piece here is the iron, right? So we're gonna have Q lost is the one for the iron. And which one's gonna gain? What's our cold object here? Our cold object here is the water and copper, right? Is it water alone and copper alone? No, it's water and copper that are both gonna gain. So water and copper. Okay, this is the first thing. Whenever you see thermal equilibrium, first identify your Q lost and your Q gained. Okay, after you identify your Q lost and Q gained, what do we know is going to happen to the Qs? They're going to be equal to each other. Why? Because it's called thermal equilibrium. So they're equal. They're equal to each other. So let's see. Q lost. We're going to write down if this comes written. Q lost equals Q gained. What is the Q lost? Q lost is the iron. So I need to find the Q of iron. How do we find Q? Remember, Q equals mc delta T. That's if you're working with one substance. For now, we're solving with iron, so we're working with one substance. Let's just find it. What's the mass of iron? It's 5 kilograms. The C of iron, it's not given, but you should have it. Let me open the solution. You should have it. You know, I'll open the book actually. Over here. It will be given in the exam. Physics here. I think I had it open from last time. Over here. So here's all the C's. So the C of iron is 0.48 kilojoules. Okay, so let's go back here. So the C of iron, the mass is 5. The C is 0.48 kilojoules. And then delta T, okay, we don't know, right? We're trying to find the temperature. We don't know how much it was, right? But we know that its initial temperature was 60 degrees Celsius. Since our other temperature is in Kelvin, let's just convert this one to Kelvin, so we're working with the same amounts, okay? 60 plus 273 is 373, okay? It's 373, okay? This is the Q of iron. It shows 373, it's delta T, so 373 minus the final temperature. We don't know what the final temperature is. They want us to find the final temperature, right? They want us to find temperature final, okay? And yo, chat, did the live finish? Yeah, it didn't finish. Hold on. My tablet's bugging. Okay. So this is Q lost, okay? This is Q lost for the iron. We're gonna equate this to Q gained now, right? Q gained is for water and copper. So people will say, okay, you're gonna write Q equals MC delta T again. I'm gonna tell you no, it's wrong. Because why? We're not using one substance, we're using water and copper. So we need to find the C of the system. And what did I tell you guys? How do you find the C of the system? The C of any system is equal to C1 M1 or M1 C1, whatever, plus C2 M. Okay, I'm getting a call. Say from Oman. Yeah, I'm a decline. يا أخي إيش بدك؟ You should use this one. You should use this one. I can't. I'm using it. I can't. I seriously can't.
What
5 minutes.
use
5
this
minutes.
one? Why don't
5
you
minutes.
use this
5
one?
minutes. 5 minutes. Okay. Anyway, yeah, you're gonna do this to find the C of the system. What's my first substance? It's water, right? So the C of water, which should be given. Once again, it should be given. Okay. Here the C of water is 4.2 kilojoules times the mass of water. It's 3 liters of water, so that's the same as 3 kgs of water. Okay, plus the second C, it's copper. The C of copper, you go to copper. The C of copper is 0.39. So you write 0.39 times the mass of copper, which is just 1. Okay, if you put this in a calculator, guys, you're gonna get 12.99. Okay, now that you know the C of the system, okay, now that you know the C of the system, you do Q equals capital C delta T. Okay, you don't use MC delta T. You only use this equation for one case, and that's when you're using a system. Okay, only when you're using a system. Okay, Q equals C delta T. So now, and I know what my capital C is. It's 12.99. I can just write 12.99 times delta T. Do we know what the delta T is? We don't know what the final temperature is, but we know what the initial temperature is. So it's going to be temperature final minus initial temperature 300. I'm going to give you a tip. Not that it usually matters, but my advice to you is always start with the bigger temperature. Okay. In this case, we know iron is going to cool down, so its final temperature will be smaller. Okay. And in this case, we know that the water copper system will start to gain energy from the iron. So the final temperature will obviously be higher than its initial temperature, so it's going to be gaining energy. Okay. Now, when you do this, you can put this all in a calculator. Okay. And like over here, you can put it in a calculator in your whatever. You're going to get 5 times 0.48 times 373 minus x, okay, equals 12.99 times x minus 300, and you press shift solve and you get 311. So TF, you're gonna write TF equals 311 Kelvin, just like this. Okay. Let me see the chat. I missed a lot. Oh, Karam. Okay. Show how to do all the conversions. Okay, conversions for what? I don't know. Uh, Walid, are you doing this for the money? No, nigga, I'm not doing it for the money. Where do you find all the experiments in the book? Uh, just open my notes. I have all the experiments in my notes. Can you do the topic questions? I don't know what the topic questions are. Uh, okay. 60 plus 273 is 333. Oh shit. Oh shit. Yeah, 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 yeah. 333. Okay, yeah, yeah. I did not see that. My fault, gang. 333, and instead just put 333. But it barely made a difference. I think also the answer is also 311. I'm not sure. Okay, will this count? I think, yeah. Yo, what for ask physics region to leak the written? Wallah, I wish. How do you know where to put the F? Okay. When writing delta T, when you write delta T, always start by writing the bigger temperature first. Okay, that's will always work. Okay, Watfa, start uploading on Kick. No, Watfa, can you please explain the experiments, the one in the course division? Okay, I will do that. Okay, uh, will experiments come in written? I don't think so. Can you solve exercise 1.10 and 1.111? Okay, I'm gonna. Oh, mm, okay, I just got a 10 dirham donation. Okay. ماشي. Let's celebrate their first super on a live stream. مناقيش for tomorrow. ماشي. Thank you. Thank you so much, Eunice. Yo, how do I hold on? Is there like something I can do? Yo. What's this warning? The stream HI? Warning, the stream current bitrate is lower than the recommended bitrate. We recommend that you use a stream bitrate of 6800. Okay, open studio. Let me check. Hold up. How do I change the bitrate? Yo. Guys, what's this? Yo, what happened? Okay, let me close this. Let me close. I'm tweaking. Okay, I'll fix that. I'll fix that for the next stream. Okay. What do you think will come written? What I think will come written. This is what I think will come written, guys. Just let me hide my screen for this. I can't. I'm opening my files. Drive. One sec. This is what I think will come written over here. Open with. Okay. Just give me a sec, guys. Okay. Yeah. So this is what I think will come written. This question all the way at the end. Something like this, something similar to this. Okay, something similar to this question. Okay, I explained it in the notes video. You can go back and watch it. Okay, make sure to know how to solve it. I also think P1 V1 or P2 V2, these V1 over T1, whatever. I think all of these will come. Okay, let me go here. Okay, let me see. Uh, do you memorize the experiments? What for or no? I don't memorize experiments. I try to understand. Uh, what do you think could come? Why the live look like? Okay, why do you do Ti minus Tf, not Ti minus Tf? Okay, listen, for delta T again, guys. For delta T, you guys usually know that it's Tf minus Ti. As long as you make your answer positive, it doesn't matter. But for me personally, I like to put the first temperature. I don't care, and I just put T1 minus T2, whatever. I don't care. I don't care if it's final initial. What I like to do is I put the first temperature as the higher temperature. Okay, that's what I do. The first temperature as the higher temperature. Okay. Uh, from OBS. Okay, are you going region football? No, man, I'm too old. Your voice is so low. Is it low? I don't know. Written predictions, like I told you, they will probably get Q equals MC delta T. Uh, they will probably get P1 PV over T, the P1 V1, P equals P2 V2.
Please,
What do you want to
are
do?
you sharing your screen?
Yeah, I'm sharing my screen.
I'm your brother.
Okay, guys, my brother wants to say hi. Okay, let me see. I'm gonna go over the experiments because I think it looks like Habib, no one can see you.
Oh,
No one can see you.
but they can.
No, they can't see you.
Lost.
Go sit, go sit, go sit. Q lost is the one with the least temperature or what? Okay, Q lost. Okay. Oh, FN greater than physics. Honestly, okay, okay, Jad. I don't know who this is. Okay. Oh, okay. Damn, guys. Okay. Wow. Thank you so much.
Physics.
I got. Okay. Thank you for the donations. I guess that's a whole broad pass. Yeah, it is. That's a broad pass.
Oh, can I spend the ball pass?
No, hell, Annie, Habib, my money. Go sit down. Okay. guys, shit. Jad Aji. Okay. To answer George's question, okay, Q lost. Okay, this is the one that's hotter. This is the hotter object. Okay, because the hotter object is the one that loses energy. Okay, then the Q gained. Which one's gonna gain energy? Obviously, the colder object. Okay, Jad and Shobaki, thank you so much for the donations. Wallah, I really appreciate it. I don't know. Okay. Anyway, I'm gonna solve the.
Another one.
Another one. More money ish. Thank you.
More memory.
Thank you, guys. Thank you, guys. Guys, wallah, I don't want that much money ish. Okay. Fuck. My tab is tweaking. Why is it opening? Okay. Okay, every time I get a donation, the same guy is typing, you got 53, and then it was, okay, thank you for counting how much money I'm getting. I appreciate you. Okay, I'm gonna do the experiments in the course revision. I'm gonna scroll down. Let me see. I think they will get this question in the computer part, guys. Okay. The temperature of an object is a measure of the average kinetic energy. That's true. Moving a body increases kinetic energy. True. The molecules of a hotter object have higher concentration of heat than those of a colder. Akid. This is true. Okay. Fast moving molecules have a higher temperature than identical but slow. True. Bodies can become hotter by converting their mechanical energy of microscopic motion into the kinetic energy. True. But the converse is false. Okay. Make sure you know this. Okay. Most profitable vid until they, yes, do 12. Okay, this guy's spamming. Okay, ماشي, I'll do 12. Yalla, let's do 12. I'll do 12 and then you know what? I won't do 12 now. I'll do the experiments first because haram, they asked a lot. Okay. Those two, yeah, I think it's these two questions. Okay. Design, let me open the solutions. Physics. Solutions.
Did I introduce myself?
Course.
Did I introduce myself?
Yeah, everybody knows you. No, this is grade 10. Why do I have grade 10? Do I not have? Yes. Do I not have the solutions downloaded? Oh, it's physics. I'll download it again. Okay. Waleed, leave your stream on when you're sleeping and point the camera on you. Okay. Okay. Yeah, sure. Guy, is the quality actually lacking? It's very blurry. Okay. Let me see. Okay. You know what? We're gonna add a notepad. Okay, let me see. Notepad. Okay. We're gonna solve question 13, 14, then 12. Then I'm gonna do 1.10, 1.111 in the book. Okay. Okay. Guys, don't waste your money. Guys, move shay. Don't do this. Converse means opposite. Guys, ya Allah. 7. Okay. Shobaki told me to get you to 100. Guys, okay. Guys, voila. Yeah, have you sit down? Okay, you can show this. Okay. Show message.
I love you multiple.
Anyway, guys, thank you so much for the donations. Okay, Ahmed, Jad, Sigir. Okay, Walid, nice acting, buddy. I want a nice acting. يا حبيبي كل خرا. ايش acting? I don't know, guys. I've never been in this situation. عمر فتحي. Okay, explain experiments, please. Okay, ماشي ماشي. Guys, stop donating. والله مو بشيء. والله stop donating. I actually want to explain. والله I actually want to explain. Okay. Okay. Shit. Aha. I made more. Oh my god. Okay. Okay. 13, 14. These are the experiments in the course. Okay. Oh my god. Jad made me match him. Guys, wallah, don't waste your money. مو بشيء. مو بشيء. Okay. Question 13. Okay, I'm not gonna look at the chat, guys. I actually want to explain this. Okay, we want to design an experiment. Okay, we want to design an experiment to determine the specific latent heat of vaporization of water using electric heater. Okay, guys, what does latent heat of vaporization mean? Vaporization is going from liquid to gas, right? Liquid to gas. Okay, and I saw Rami Malik. What, Mr. Rami? Okay. Why is my guys, my economics teacher? Okay. Okay. Vaporization is going from liquid to gas. Okay. If you want to design an experiment, Akid, you're gonna need something. You're gonna want to boil something, and you want to see how much was boiled and whatever. Remember, guys, the equation for vaporization is Q equals M LV, right? This is Q equals M LV. If we want to know how much LV is, it's going to be Q divided by M. This is the first step you should do. How do we find what the latent heat of vaporization is? We need two things. We need the energy needed to change this liquid into a gas, and we need to know how much mass of liquid I changed into gas. How do we do this? Let's see. I'm going to open the solution and I'm going to read the solution and then tell you the way I do it. So, they said, I'm going to write the formula on the side, okay? Q equals M LV. Okay, thank you, Ziad, for the donation. $1 donation. Thank you. Q equals M LV. So, if you want the latent heat of vaporization, that's the experiment we're trying to design. It's to show what the latent heat of vaporization is. It's Q divided by M. Okay, let's see. They're saying connect an immersion heater to the power supply. The heater will provide us with energy, right? That's the heater. It's going to provide us with energy. We're going to fill a beaker with water and we're going to cover it and weigh the mass. Okay, so we're going to take a beaker, fill it with water, okay, and we're going to cover it. Okay, you guys know how we cover it. Okay, let me change this to blue because it's water. Okay, هيك. Okay, this is blue. They said heat, insert the heater, and we want to boil it, right? We want to insert it. What if I use this to buy juice and chips? Okay, thank you guys for the donations. Thank you, Sigir, again. Thank you for Hamdan. Thank you, Hamdan, again for the donation. Okay, we want to insert the heater and we want to boil it. Okay, so the water, after you heat it, is gonna start boiling, right? Remove the lid. We're gonna let it boil, and we're gonna remove the lid quickly. Let some steam escape, and then we're gonna close the lid again. Okay, when you let the steam escape, we want to see how much Q we have. How much energy are we supplying right now? Okay, we want to see how much Q we have. Remember, we need two things. We need the Q and the M. We open it. Before you open it, by the way, you get the mass. You weigh it. You want to see how much water you have. You open it. You check how much energy you're supplying. Then quickly you close it again. Okay, now after you closed it, some steam would have gone outside, right? Some steam would have gotten outside. Okay, after the steam goes outside, the mass, of course, it's gonna be a new mass. It's called mass 2, right? This mass 2, it's gonna be less than the original mass 1, of course, right? It's gonna be way less than the mass 1 because steam escaped our container. Okay, so we want to see how much steam, right? So how do you do that? You want to subtract the second mass by the first mass, okay, to get whatever, delta M. Okay, let's say the first mass was 75 grams. It's 73 grams. We subtract 75 minus 73, or the other way around, it doesn't matter. Okay, you're gonna get 2 grams. As long as you make your answer positive, that's what matters. Okay, you make your answer positive, you get 2 grams. So that means 2 grams of steam evaporated, right? Evaporated. 2 grams of steam evaporated. Do we know how much Q now? We read the Q at the start, right? Hella, let's see how much energy are you supplying. This was Q1. We want to see now how much energy are you supplying after it evaporated. Okay, we're gonna get Q2. Let's say here it was 7,500 joules. Now it's, you're not supplying more energy because it's not going out. It's gonna be 7,400 joules or whatever. Okay, again, you're gonna see how much energy you had to supply to evaporate these 2 grams. So you subtract these two energies. Okay, it's gonna be 7,500 minus 7,400 equals 100 joules. Okay, this 100 joules, you have now your energy, you have your Q, and you have your mass. Can we find what our LV is? Yes, you just do the Q, which is whatever number you get, 100, divided by the mass, which is 0.02. Remember, in physics, you make it in kilograms, okay? You get this and it becomes whatever, whatever, I don't know, whatever answer you get. But this is, obviously, these numbers are inaccurate. These numbers are inaccurate, so don't count on them, but I'm just trying to give an example, okay? So, let's go through this again. We get a beaker, fill it with water, and put a heater in it. We close the lid and start boiling it, okay? When you start boiling it, you see that it started to boil. Quickly remove the lid. Okay, no, before you remove the lid, sorry, weigh it, find your mass 1, right? We find M1. After we find M1, okay, we're gonna open the lid, let some steam escape, see how much energy it took for that, okay? And then see how much energy it took from that, sorry, and then close the lid again, okay, to get our new mass. We don't know what the new mass is, mass 2, whatever, mass 2. This mass 2, we're going to subtract the final mass by the initial mass to see how much steam escaped. So if it was 75 at the start, 73 at the end, we subtract to see that 2 grams of steam escaped or evaporated or whatever. And then we're going to read our final energy level. Okay, you subtract again your energy levels to see how much energy you actually needed. Okay, and then you use LV equals Q over M to find it. Okay, so let's read it. Insert the heat, allowed to boil, remove the lid so that steam escapes, and at the same time read the joule meter. Okay, Q1, and then switch off the heater. We want to subtract the masses, subtract the Q's, and then see LV equals delta Q over M. Okay, yeah, whatever. So let's see. I hope you understood this. Let me see. Oh, that's a lot of donations, guys. Okay, 10 dirhams from Amr Fathi. Thank you so much, Amr. Rania Shakir, $1. Thank you so much, Rania. Ziad for the 200. Thank you so much. Fuad was grieving. You saved us. Thank you so much. Okay. Jad saving us from Fuad. Thank you. Zaid Khoury, pick a number from 1 to 10. 9. Oh shit, that's 100. Guys. Guys, what the
Oh my god.
يا ربي.
Wow, you didn't answer.
Adam, يا عم, go روح. Okay, I picked 10. There's a chat delay. Shamil, 11 dirhams. Zaid, wow, you didn't answer. I didn't mean it like that, يا man. It's because there's a chat delay. My mom's calling me, guys. My mom's calling me. Wait. Okay, I'll go get it now. Okay, يلا, bye. Bye.
You just made 400.
Guys, wait, I have to get my food. Wait.
Guys, what's up? Okay. They keep saying Adam.
يا أخي, قوم.
Yeah, you got 400.
Okay, I got my food, guys. Log in for me and do the exam to thank you. No. Waleed, they're using their mama's money on you. Yeah. For the 400, thank you. Thank you so much for the donations, guys. Honestly, I don't know what to do. For the next stream, I'm gonna try and like get something to like start popping up in the live when someone donates. uh, but like guys, I wasn't really expecting donations, honestly, wallah. So thank you so much, wallah. I appreciate it. يا اخي انت يا اخي بس بهمك المصاري. جو حبيبي، روح. Before I start, question 14. Is quiz enough? Is quiz enough for the exam? No, definitely not. I'm gonna add a mod because guys, like, wallah, wait, hold up, let me add a mod because there's a lot of stuff in the chat happening. Top question 37. Shoot top question 30. We don't really need tops. Okay. Let me hide this. Okay, how do I mod someone? Engage. Oh shit. Yo.
Oh.
I don't think I can mod right now. I'll fix that later. Uh okay, thank you Splashy for the $1. Okay. I'd be an amazing moderator. You guys, I already have a few names in mind. Okay, question 14. My phone is exploding. Okay. Design an experiment now for the latent heat of fusion. Remember, fusion يعني melting. Okay? That means going from solid to liquid. So how the experiment works is you go here, connect the electric heater to a power supply again. Okay? We want a heater. You always need a heater. Remember, latent heat of fusion, we're trying to measure it now. LF. Remember that Q equals MLF. So if you want to find the latent heat of fusion, it would be Q over M, right? So again, we're going to need the Q, we're going to need the M. So what we're going to do, we're going to fill a beaker with water again, okay? We're going to put certain blocks of ice, right? Blue blocks of ice. Let's say I put 10 grams, okay? Now we want to melt this. So we're going to see they're using an ammeter. They're using an ammeter. Where is it? Yeah, they connect. Yeah, they're using an ammeter for current and a voltmeter for volts. Okay. In the exam, I think if they were to get it in the computer, they would just ask about the formula. Okay. You would have to use, since we're using an ammeter current and voltmeter for volts, we're going to use I V T over M. Okay. Latent heat of fusion. We're going to turn on. We're going to turn on the heater now. We're going to record how long did it take to heat these ice cubes for them to fully melt, right? After that, when they melt, we're going to check how much current, we're going to check how much voltage, and we're going to check how much time, right? So we're going to do I times V times T divided by the mass of the ice cubes, and you're going to get whatever answer, blah, 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 that you got. I hope you understood. Oh, guys. لا شباب حرام والله not on جاد أيوب مو بشيء يعني. I'm getting attacked والله حرام. Okay, هلا we're done 13 14 12. Let me do 12. my throat يا أخي سأل يا أخي سأل شو بتحكي؟ يا أخي سأل لا تستهبل. والله I actually didn't understand what you said, Jabab. Okay. Yeah, thank you for counting my money. Khairi, whoever this is. I appreciate it, bro. Okay, I'll take the mod. Remember who dropped you off yesterday. Okay. لا استهبل. Oh shit, okay. Okay. Question 12. Okay, somebody asked for this. Do we memorize the table? No need to memorize. Okay. How do we know? Okay, before starting this is a very good question. It has to do with the question I'm about to solve. Fizaria asked, how do you know when the question is asking about the small c or the big C? Okay. Small c, 99% of the time, you use Q equals MC delta T. Q equals MC delta T. You're going to use this, okay? You're going to use this equation. It's a small c. But, okay, like in the question 11. Okay. هولي سهلين لا تستهبل. Okay, like in the question here, question 11. Okay, I was using water with copper together. Okay, that is when you have a system. When you have a system, you can't use Q equals MC delta T to find the Q of these two together. No, you actually have to do, you have to find the C, capital C, of this system. So whenever you have two materials together and you want to find the Q of two materials together, you need to do capital C. Okay, and capital C equals M1 C1 small c1 plus M2 C2. That's when you use it. Okay. هلا question 12. Okay, they told us a 2.2 kilogram piece of lead is placed in an aluminum beaker. Okay, so we have lead, aluminum. Okay, and the mass of it is 500 grams of that aluminum. It has 10 liters of water, so we have three materials: lead, aluminum, water. Okay, and then they heated it 2000 watts. Okay, it went from 20 to 80 in 21 minutes 22 seconds. Determine the specific heat capacity of lead. Give one factor that explains the difference between the calculated value and the actual one state. Okay, let's forget about the last part. Okay, نحنا we have three materials. Okay, all together we have a Q, right? Q. This Q is coming from the heater, right? From the heater. The heater is supplying power 2000 watts in certain time, 21 minutes 22 seconds, right? Okay, it's heating up three things, right? It's heating up the Q of lead, right? It's heating up lead. كمان it's heating up water. وكمان it's heating up what? Aluminium, right? It's heating aluminium. So this total we can find, we can find the Q of water, we can find the Q of aluminium, because in the exam they will give you the heat capacity of water, they will give you the heat capacity of aluminium, but they're asking find the heat capacity of lead. Find the heat capacity of this lead. In the exam they won't give you the heat capacity of this lead, and I'm going to tell you the C of water, okay, is equal to 4.2 kilojoules. Okay, with the C of aluminium is equal, I think, 0.42 or 0.39. Oh, I closed that by accident. Oh shit, closed it by accident. How do I open something I just closed? Yo, ya Allah, don't tell me I lost it. Oh no, it's here. Okay, aluminium is 0.90. Okay. Okay, 0.9 kilojoules. Now you can find this. The Q total, it's supplied by the heater. We have the power and we have the time. Can't we just do, isn't Q, guys, equal to power times time? Yes, it is. So the power is 2000. With the time is 21 minutes 22 seconds. Okay, 21 minutes 22 seconds converted to seconds. You do 21 times 60. Clear. 21 times 60 plus 22. It's 1282. Okay, so the Q total is 2000 power times time. 2000 times 1282 equals, okay, the Q of lead. What is Q of lead equal to? Guys, Q equals MC delta T, صح? The mass of lead is 2.2 kilograms. Okay, the C of lead, we don't know it, so we're going to say C of lead times delta T. Delta T for all of them is going from 20 to 80, صح? So 20 to 80. So 80 minus 20, it's 60. Plus Q of water. What's the mass of water? 10. Times the C of water, 4.2. Times delta T, again, it's 60. It's 60 for all of them because all of them went from 20 to 80. Plus Q of aluminium. Aluminium is 500 grams, so 0.5 kilograms. Times C of aluminium, which is 0.9. Times delta T, which is 60. Okay. Halla, you're going to rearrange a bit. Okay, we're going to put this all in a calculator. Okay, let's see. 2000 times 1282 equals 2.2 times, we don't know what C of lead is, so we're going to change it by X, times 60 plus 10 times 4.2 times 60 plus 0.5 times 0.9 times 60. Shift solve, you get this. This is in kilojoules. Did I forget to convert something? Ah, yes. Okay. You should see here. This is in joules. Okay, this is in joules. But I put these heat capacities in kilojoules. Okay, so to make it, I put this is in kilojoules. But to make it in joules, you should divide this by 1000. So let's just replace this by 2 instead of 2000. Okay, let's change it. Okay, shift solve, and you should get, yeah, 0.128. Okay, you're gonna say, طب Walid, why is your answer different than the one in the course revision? Okay, in the course revision, they used this C here as 4.18. Okay, that is also correct. If you use C as 4.2, it's correct. But in the exam, you won't have to go through this trouble because they will give you C themselves. They will say use C as 4.2, for example, or use C as 4.18. Okay, let's see. Uh, Thank you again, Hope, for 18 round. Yes, ادعي حق. والله I can't see. Let me. ادعي حق يوسف ويوسف بس. الله يوفقك ليوسف. Okay. I can't see anything here. 2 years of Ma'id made less than 1 hour. Okay. I'm gonna continue هلا. They told me to solve the book exercises. Someone here said solve 1.10, 1.11 in the book. I'm gonna solve those because maybe they're gonna come. Let's see, open ebooks. It's 1.2. Just give me a sec, guys. These. Okay. Let's see these. A car tire was tested. What do you think will come for the written? Q equals MC delta T. Something to do with that. A car tire. Wait for a moment. A car tire was tested before being driven on a motorway. The reading on the tire pressure gauge, which reads the atmospheric pressure, was this. Okay, which is 120,000. This is the same as Pascal. Okay, and the temperature was 7 degrees. At the end of the journey, the temperature of the tire was found to be 35. What reading would you expect on the same tire pressure gauge if the volume of air remained constant and then atmospheric pressure throughout the journey was also constant? Let me see. So if volume was constant, yani P1 over T1. Okay, what reading? Okay. Oh, okay. Yeah. So they said the volume remained constant. Guys, PV over T. What happens if volume is constant? We're going to use the rule P1 over T1 equals P2 over T2. Okay? So for this one here, you're going to solve عادي. P1 over T1 equals P2 over T2. Okay? What's P1? It's 120,000 pascals. So you could just say 120 kPa. Let's change it to kPa because it's easier. I don't like working with too many zeros. Over T1. Okay, it's 7 degrees Celsius at the start. Okay, at the end of the journey. Okay, yeah. So it's 7 degrees Celsius. Let's change it to Kelvin by doing plus 273. You're gonna get 280. Okay, so 120 over 280 equals P2. We don't know what P2 is. We're trying to find what the new pressure is. Over T2, 35 plus 273, which is 308. Okay, let's cross multiply and I'll show you what to do. Your answer will not be the answer you get now. You're going to have to do an extra step here. Okay, 120 over 280, okay, equals x over 308. Okay, this is a very good question, guys. You're going to get x equals 132 kilopascals. Okay, but they said atmospheric pressure throughout the journey was also constant. Okay. هلا I'm not sure. Let me see the answer they put in SDP. It should be 12, but I'm not sure. Let me see. Okay, the reading, it should be, let me see if this is correct. It's not correct. Yeah, you're supposed to put, I think, 12. 1, 2, 3. What's the answer? Should get, okay, the reading on the tire pressure gauge. Okay, 120,000. Honestly, I don't know. Let's check the solution. This is a very good question. I think I forgot to do something here. 1.10. Let's see the solutions. Solutions should be here. Oof, la la, I went too far. 132 kilopascal. Yeah, it should be 132 kilopascal. I think the ILS is wrong. Uh, Answer is 140,000. 140,000. I can see you. There's a chat delay. Aha, relax. 140,000. I think it's 140. Why is it 140,000? Let's see. This was what page? Ya Allah, I have to find the page now. It was somewhere here, right? Hold up. Here, page 14. 140,000? How's it? No, how's it 140,000? Okay. Okay, a car tire was tested before being driven. The reading on the tire pressure gauge. Okay, you said 140,000. Let me see. 1400. Sure, it's not. No, your answer is wrong. Maybe I'm converting wrong. No, area divided by force. Yeah, force divided by area. Okay, so the reading on the tire pressure gauge, which reached the pressure, was 120. Okay, at the end, it was hotter. Okay. Since it's hotter, yani, the pressure should have increased. Okay. The reading we would expect on the same tire pressure gauge. Oh, 242,000? Are you in 252,000? No. I think I have this solved in my physics copybook. 1 second. 1.10. Let me see. Oh, this is my mechanics copybook. Inshallah, everyone gets good tomorrow. Yes. Thank you so much, Lisa, for the donation. I hope so as well. Let me see my notes. Uh, see my notes.
The QS is wrong.
The question is wrong. I don't know. It should be. I think it's wrong. I think I remember solving this with my physics teacher. The same question. I remember solving it. Let me see. Okay, gas equation. Exercise 12, page. What page is this, guys? It's page 14. So 1.13. Did I solve 1.10? No, I didn't solve it. No. Put it in ChatGPT. Yeah, actually, let's put it in ChatGPT. ChatGPT. I swear on Adam, the answer is 142. Okay, let's see. 1.10, صح? Okay. Okay, guys. How the fuck did we get 142,000? How do we get 142,000? Okay, I got 132. Oh shit. Okay. Yeah. Okay, it reads the pressure above the atmospheric pressure. Okay, I read it wrong. Okay. Let's see. This tire, it reads the pressure above atmospheric pressure. Listen, I'm gonna tell you guys from now. The physics regional, I heard this from someone. said, and he told his class to make sure to read the questions very carefully tomorrow, because he's gonna get a question where you have to read it properly. If you don't read it properly, you're gonna do a miscalculation. He said this, and it's not me. Okay, so the reading on the tire pressure gauge, which reads the pressure above the atmospheric pressure. They're not saying that atmospheric pressure is 120,000. You guys should all know, and I forgot, atmospheric pressure is 10 to the power of 5 pascals. Okay, it's 100,000. 100,000 pascals. So the pressure actually here, the pressure here was 120,000 minus 100,000, which is 20,000. Okay, so this is the initial pressure. So let's do P1 over T1 equals P2 over T2. I think this time we should get the correct answer. Okay, pressure 1 is 20,000 pascals. Let's just say change it to 20 kPa. T1 was 7 plus 273, 280 equals P2, which is, we don't know it, over T2. 273 plus 35 was 308. Okay, we cross multiply. Let's see this time. I think it will be correct. Walid, in 2 minutes, start on the physics region. No haram, the physics region, Mr. Hani. Very nice guy, wallah. 308. Okay, x equals 22. Okay, 22. 22 kPa. This is how much is inside the tire, right? Inside the tire. How much did we have originally? 120 kPa. Remember, this gauge or whatever pressure instrument, it's reading the outside, and they said that this atmospheric pressure outside was also constant. Okay, so they're saying, and don't forget about this 120 kPa. It's stayed there. Okay, the barometer is reading that one as well. So this 120 kPa plus this 22 kPa gets me 142 kPa, which is 142,000. Okay. Anna, I'm not sure. Yeah. Yeah, I think that's correct. I'm getting voicemails. Whoa, okay. Okay, let's solve 1.11. وخلاص, I think we're gonna call it a day. 1.11. An empty bottle is corked. Guys, if you want my advice, I think you should do these two for all these exercises. إذا تريدوا تجيبوا زين خبروا أمهاتكم تدعوا لكم. صراحة معك حق. Can you explain again? I disassociated. Just watch the playback of the recording. How do you guys know so much about the region? We didn't even know what they might get for written. No one told us. No, it's because the regional actually teaches a class. He teaches a class. Okay, question 11. A car tire. Okay, an empty bottle is corked when the air inside at 10 degrees Celsius. Okay, and the barometer reads 75 centimeters of mercury. So the pressure is 75 cm Hg. Okay, if the cork blows out when the pressure inside the bottle exceeds the atmosphere's pressure by 100 centimeter of mercury, so the cork blows out when the pressure inside is greater than 100 centimeter Hg. Okay, calculate the temperature to which the bottle must be heated to cause the cork to be expelled. Assume that volume remains constant. Remember, PV over T. Volume constant, yani P1 again over T1 equals P2 over T2. This is again an interesting question. To cause the cork to be expelled. Okay, so نحن this is easy. It should be a direct application. Our pressure 1 at 10 degrees Celsius was 75, so 75 over 10. Our pressure 2 is 100. And our T2, we don't know it. We're trying to find it. Not 10 degrees, sorry. It should be in Kelvin. So 10 plus 273, 283. Okay. This should just be simple cross multiplication. Okay. Here. Let's cross multiply. 75 over 283 equals 100 over x shift solve should be 377 Kelvin. I'm not sure. Let's check. If they want it in degrees Celsius, let's see. What do they want? They want it in degrees Celsius. Yes, so let's subtract. Let's subtract by 273 since they want it in degrees Celsius. It will be around 104 degrees. Oh shit. Am I tweaking? 100. Guys, am I tweaking? Yes, yes, make sure to do the notes. Did I do something wrong? 104.3. Okay. Ah, 175. Okay, okay, 175. Yes, 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 yes. 175, okay. So the pressure inside, okay, the air inside is 75. Why 175? What is the temperature? Okay, to be expelled, okay, if the cork blows out when the pressure inside the bottle exceeds the atmospheric pressure by 100. Okay, okay, exceeds by 100. Okay, exceeds يعني you add. Okay, exceeds يعني more than it by 100. So it's more than 75 by 100. So 175. See guys, they like to do this fake wordplay ما بعرف شو. Make sure you do it. Also make sure you pay attention to the question. أنا in the exam I will be reading the questions twice honestly يعني. Right now I'm not really reading because we're not in the exam, but you should always read the question, double check. Okay, let's do this again. 75 over 283, okay, equals 175 over x shift solve minus 273, you get 387.33. Okay. So 387.3, this is should be correct. Yes. See guys, pay attention to the word play. Let's see. Walid, you talk about Mr. Hani a lot. I don't know. Walid, can you fix the quality for next time? Yes, I will. Sigar Nofal says he loves you. Uh, I think I love you guys too. I think. Uh, I made 490. Thank you so much for the donations, guys. Before I end the stream, is there any questions you guys might have? Really quickly. Let me wait a bit. يا أخي شو English? No, not English. Can you do section 1.3 question 1.7?
Oh, you, yeah, we reached 500.
يا أخي بس 500. Okay, 1.3 1.7. I think you should be able to rewatch the stream. Thank you so much Jad for the donation. uh خلاص man جاد يا أخي why are you يا أخي, you don't have to man. Allah. Okay, section 1 point section 1.3. Oh, never mind. My mom came guys, I have to go eat. Thank you so much. uh you just have to understand. Khas, thank you guys so much for watching. To everybody who donated, you really didn't have to, wallah. uh thank you guys so much. Until next time, thank you. Bye.